Okay, so I want to show how to multiply 2-digit by 2-digit factors using the area model and the array. So if I had the numbers 23 and 16, making an array means I'm going to represent the rows and columns. Now I know this is going to be different than the standard algorithm, which is the simple line them up and multiply that most people are used to. But this is a really important component of understanding the visual so that students can understand the process that they're performing. And it will really help in the long run about grasping what exactly they're solving. So what we do is we start by decomposing the number. So 23 is made out of 2 10s, which is 20, and 3 1s, which makes 23. And the same thing is true for 16. It's a set of 10 and 6 1s. So what we're going to do is we're going to take these values and we're going to display them around the area model. So the reason there are 4 sections is because these are my 4 values. So I have the 2 sets of 10s and the 2 sets of 1s. So because 23 is my first number, I'm going to put it across the top. That's going to be 20, 3, 10, and 6. So what I'm going to do is I'm going to start multiplying each of these values against each other the way you would when you do the standard algorithm. So the way most of us are used to is by lining up the digits and then multiplying. As you go from the 1s, you would start with the 6 and the 3 and get 18. You do the 6 times 2 is 12 plus 1 is 13. Put your 0, move over to the tens place. 3 times 1 is 3, and 1 times 2 is 2. Ignore the 1. And then add, and that's much faster. The problem is kids get lost, and then they tend to just solve the 6 times 3 and 1 times 2, and they get a number that's way too small because conceptually they're not understanding what they're doing. They don't grasp that the number needs to be 16 sets of 23 or that you're multiplying each of these values. So the way we've been learning it in class is that if we start here at the top, 20 is essentially 2 sets of 10. So those are those base 10 blocks that they've used since kinder or first. The long flat one's 100. The skinny column one is 10. And then the little rectangular cubes, those are a value of 1. So here, 20 is 2 of the 10 rods, 3 1s. So there's 23. And then 16 would be 1 of the 10 rods and then 6 1s. So the way we've been learning it is to make the connections to arrays that we learned in 3rd grade, where when we had something like 6 times 3, which we're going to see here in this representation, this is 6 groups of 3. So when they initially learned multiplication in 3rd grade, it's 6 rows, and then each row has 3, and they go through and they add all these little dots painstakingly one at a time. And when they're done, they can see that 6 rows of 3 is a total of 18. So they're going to do that here, but they're going to do it as an array. So this is called an array because they are arranging the dots in rows and columns. So here, the way we initially did it on day 1 was that if this is 2 rows, 2 columns here to make 20, and then one row of 10. So then what I'm doing is in this box, I would be representing this here as, so here this is 10 rows of 10, which the students are familiar with, makes 100. It's 10 times 10 is 100, so here's a set of 100. Over here, I would have another 10 rows of 10, which makes 100. In this box here, so here this was 10 rows of 20, going to equal 200. In this next box, this is 10 rows of 3, So then if I kind of went like this, they would see that this is 10, 10, and 10. Because 10 rows of 3 is 30. Now, technically what I should have done was place dots like this 10 times, but that would take a long time. So we've just been using the knowledge that 10 rows of 3 and 3 rows of 10 are the same. So 10 times 3 is 30. Here, this would be 6 rows of 20, so then we could represent that by doing 20, 20, 20, 20 over and over and over. But what they're really doing is the 6 rows of 20. And so if they were to go through and make all 6 rows of 20, they would see that it's 1, 2, 3, 4, 5, 6, and then 12. So it's 12, but it's 12 sets of 10. So it's 120. So if you count them all, you'd get to 120. And then in this last box, it's that standard 6 by 3. So it's 6 rows of 3, which they could make all those little dots, but it would take them forever. 6 times 3 is 18. So when they're all done, they add 200 plus 30 plus 120 plus 18. And they add. They get 368. So I know this is a really, really long-winded way to do this simple algorithm here, but they're understanding that they're making groups of 10s, groups of 20s, groups of 30s every time they're multiplying, because what this is this is 6 groups of 20, the 6 groups of 3, and then 1 group of 3 and 1 group of 20. And a lot of students don't understand that, so then when they get this number and they get something way too small or way too big, they have no way to understand why they have the wrong answer. So then another way that we've learned to do that is to do this same question here, 23 times 16. Now that we did it with blocks for a couple of days, the faster way to do it is to just utilize their knowledge of multiplication. So 23 times 16, and we fill these in. So this was 10 rows of 20. This is 10 rows of 3, 6 rows of 20, and 6 rows of 3. So then they go through and they solve. So 10 times 20, they know this is 1 times 2 is 2, and this was 10 and 10. So it's 200 because you're multiplying groups of 10 by 10, which is why it was really important to do this here, to know that we were making the 10 rows of 10 here so that they understood that's why this answer has to be 200. Over here, 10 times 3, they're all familiar with 30. 6 times 20, 6 times 2 is 12, but again, it was really important to understand that down here we were functioning with these groups of 10. It helps them in understanding that this has to be 6 times 20 has to be 120 because it's 12 tens. And then finally, that 6 times 8 is 18. And again, if they go through and they add all of these values, they're going to get that answer, that 368. So your students may come home and they may explain that they've learned multiplication this way, and I know it's going to be very, very tempting to just teach them the standard algorithm here, and I promise that we will start learning the standard algorithm very shortly. But it's really important that they understand these arrays here, making rows of 10s and 1s, and then the area model, it simplifies that, and then eventually we move over into the standard algorithm. And the reason why it's really important to do all of this before you go to the standard algorithm is because, again, when you do that process, it's these same values. This 6 times 3 being 18, it's here. This is that first box. So then you see why that happens there. And then when you do the 6 times 2 being 120, here, when you do 6 times 2 is 12 plus 1, that comes from this box. This is why we solved it like that, because this is 120, because 6 times 2 is 120, or 6 times 2 is 12, and that extra 1 came from right here because they're familiar with the concept that you have to carry. So then that's where that 138 came from. It came from this box right here, or this row. And then again, when they move on into the tens place and they're done with these other values, this 1 was actually this 10 over here. So then they do the 10 times 3, which comes out as a 3 when you write the digit, but that 30 came from this box right here. And then finally, this 1 times 2, that seems pretty simple to just say 1 times 2 and write a 2. It's because it's this 10, because this is a 1 in the tens place, and this is a 2 in the tens place. It came from this box right here, 10 times 20. And then that's why when they put the 2, it's really a 200, because it's 2 in the hundreds place. So then when they add them all, again, they get the same answer. I just wanted to create this video to explain to you the processes and how we're moving from an array to an area model, and finally to the standard algorithm. So please avoid teaching the standard algorithm if your student comes home with any math homework until we've covered it in class. I promise we're going to get there. For right now, I just wanted to expose you to some of this newer math, because I know sometimes it can be very frustrating for your child to explain to you what we did in class, and it's definitely new age. It is not something that most people are familiar with, but it really helps for students to understand what we're doing. Thank you.